So now that you've got a taste of what structured concurrency is in Java from a conceptual point of view and a sort of a high-level benefits point of view, let's talk about how do you program with structured concurrency in modern Java, in really modern Java. So just to kind of reiterate, Java's structured concurrency enforces a hierarchy of tasks and subtasks. So as you can see here, we can have an enclosing scope, which could have multiple enclosing subscopes, and each subscope could have a bunch of tasks. So you can nest the concept of structured concurrency to whatever level or depth you deem relevant for your particular set of requirements. Again, the lifetime of a subtask has to be confined to the syntactic block of its parent task, so semantics and syntax come together in a nice clean way, a nice clean structured way. And sibling subtask lifetimes, these guys, are nested within the parent task to whatever level you want. OK, so why is this good? We can reason about and manage everything as a unit, and you don't have as many surprises, no leaks, no orphans, and so on. Now, as you might expect, structured concurrency is a great match for virtual threads. You can do it with non-virtual threads, but why bother? I mean, the whole point of virtual threads was to be able to create threads quickly and shut them down quickly, and yet still maintain all the other benefits of doing concurrency through threading. And so virtual threads and structured concurrency really were designed to go together, like peanut butter and jelly, or peanut butter and chocolate, depending what you like. So since virtual threads are lightweight, they can be used to represent any concurrent unit of behavior. You don't have to limit them just to CPU-bound operations. You can use them for operations or behaviors or tasks or whatever you want to call them that involve input and output or synchronizers or whatever, database operations. And we'll talk more about this example later to make the point more explicit, but at a quick high level, here's an example where we're going to use structured concurrency in order to be able to download a bunch of images from remote web servers, and there could be dozens or hundreds of these images, and we're going to download each one of them in its own virtual thread, and that works perfectly well with the Java virtual threading mechanism. There's no additional overhead there, which simplifies quite a bit of things. And the other nice thing we can do is we can make sure we don't exit the scope until everything's finished, either successfully or if things go wrong. And by the time we're done, we can return all the images, and they've been processed in parallel in an embarrassing way. Interestingly enough, Java structured concurrency is evolving. So it's changed over time. It's not what it was a couple years ago, and it continues to evolve. So let's talk a bit about that. The most popular mechanism for doing Java structured concurrency these days is called StructuredTaskScope. And it's the basic API for structured concurrency. And it's used to split a task into several concurrent subtasks within a syntactic block. Those are the examples we've been looking at with fork, for example. This was added in Java 19 as something called an Incubator feature. And you can read more about what an Incubator feature is here at this link. But essentially, an Incubator feature means it's kind of brand spanking new, and it may need to iterate a few other times in other releases of Java before they really get it right or before they remove it altogether. I would be very surprised if they removed Java structured concurrency and structured task scope altogether, but it may be evolved. There may be some new methods. They may change some names. It's not fully baked yet. So that's what an incubator feature means. And when we run our examples, we have to actually tell the Java IDE, the IntelliJ IDE, please make sure you use the incubator features, otherwise it won't compile and run. There's also another mechanism for dealing with structured concurrency that's a little bit older. It's the Executor's ExecutorService variant. And this starts a new thread or a new virtual thread for each task within a syntactic block. And it uses some more traditional features that have been around for a very long time, almost 20 years, called Java ExecutorService. And this feature is what's called a preview feature. And that means it's a little further along than an incubator feature, but it still might change a little bit. And it has, in fact, changed a bit over time. So you can learn about preview features more generally. So Executor's ExecutorService is a preview feature. StructuredTaskScope is an incubator feature. Neither of those things really matter all that much for our purposes. Just be aware that some of this stuff may change over the next year or so. The reason why people focus on StructuredTaskScope nowadays instead of Executors and ExecutorService is because they are the Executor's ExecutorService approach is more limited. And I'll talk about what its limitations are shortly. But StructuredTaskScope is really where it's at, although there are some cool things you can do with Executor's executor service, which we will use in this class, as we will discuss momentarily. So that's the end of our quick overview of how to program with Java structured concurrency. We will go into much more detail later, showing each of those examples in depth.